Hello, 8th grade science students. We're going to talk a little bit more about making ionic compounds. So this is part 2. The goal is slightly different than before. So instead of just being able to make ionic compounds, is to be able to make ionic compound formulas out of any two oppositely charged ions. So even ones that don't match up as well. Okay, here's your general rule and just something to keep in mind. Ionic bonds usually form between a metal, which is the cation or the positive ion, and a nonmetal, which is the anion or the negative ion. But we still have to make sure that the charges cancel out so that overall the ionic compound is neutral. Let's take a look at a couple more examples. Our first example is gallium and oxygen. So like before, the first thing we need to do is figure out what their charges are. Gallium is in our third main column. And if you've labeled your periodic table accordingly, that means that the gallium is going to have a charge of 3+. So I'm going to go gallium, 3 positive. Oxygen is in our 6th column, or our 6th main column, and it has a charge of 2-, which means that it will have to gain 2 electrons to become stable. Okay, now we can get our work done and try to match these up. We have a little bit of a problem now. So +3, -2, one's odd, one's even. They don't match up very well. So let's say I go and just add another oxygen ion. Now I have a total of 4 negative charges and 3 positive charges. That still doesn't cancel out. I need more positive charges. Let's add another one. So now I have 2 gallium ions. They have a total of +6 because there's 2 of them. My oxygens only have a total of -4. So I'm short 2 negative charges. Fortunately, if we add one more oxygen, now we have +6 from the gallium. We have -2, -4, -6 from the oxygen. Now it cancels out. I can write my formula. So this time I don't just need one and a lot of another one. I need kind of a combination of both. So we get gallium 2, oxygen 3, or Ga2O3. Small problem, or small hint. This is something that's a little bit harder to deal with, right? It's a little more complicated, math-wise. Here's a trick. The trick is the positive charge, or the charge on the cation, becomes the subscript on the anion, and the charge on the anion becomes the subscript on the cation. There's one little caveat that we're going to see when we try this in our next example. So 2 methods. You can still work through this, and this is the way I normally do this, is you work through it and just make sure all the charges cancel out. Or you could use a little trick where you swap the charges to become the subscripts of the opposite atom. Let's look at example number 2. Example number 2, we're going to go with lead and oxygen. So let's take a look at our periodic table. Lead is in our center column, which means it's going to have a +4 or a -4 charge. And lead is actually a little more complicated. It's something called multivalent, which means it can have different valent numbers. We're not going to worry about that today. Since it's listed first, we're going to go ahead and say that it's our cation. It's also the metal, which tends to make us think it's the cation. So we're going to say that lead has a charge of 4+ for our purposes here today. And lead symbol is Pb, so a little bit unintuitive, but there it is. Oxygen, same as before, 2-. Now, this one isn't too complicated. I think you can see without thinking too much that we just need one more oxygen to match up with the lead. But let's go ahead and use our trick and see where it takes us. So if we use our trick, the charge on the oxygen becomes the subscript on the lead, and the charge on the lead becomes the subscript on the oxygen. Okay, that's not what we anticipated. We only needed 2 oxygens to cancel out the 1 lead. So why is it Pb2O4? The truth is, this is just fine from a certain perspective. For every 2 leads, we're going to need 4 oxygens. But with an ionic compound, it's all about ratios. So our job is to reduce that down to kind of the lowest common factor. Since it's all divisible by 2, we should divide it by 2. Divide all the subscripts by 2, and we get lead oxide, PbO2, which is the answer we anticipated. So just to reiterate, our original version would be lead 4+. We have O2-. We need one more O2-. I've got 4 positive charges from the lead. I have 4 negative charges from the oxygen. and therefore PbO2, and those are the same. Okay, so we taught you a little trick for figuring out the charges, and we talked about reducing when both of the subscripts are divisible by the same number. So using some of our skills from math class there. Okay, hopefully that's very helpful. And next time we're going to talk about taking we're going to talk about naming and coming up with formulas and how those are related in ionic compounds. Have a fantastic day.